This question requires the understanding of parallel reactions topic from the chemical kinetics. Now in this question, what is given to us is that there is a one reactant A and it is giving us three different products B, C and D with three different rate constants K1, K2 and K3. The value of K1, K2 and K3 is given in the question. Also we are given that initially pure A is taken with the initial pressure of 8 atmosphere. So that means at T is equal to 0, P0 is equal to 8 atmosphere. We need to find the partial pressure of B after 100 seconds of the reaction, right? So let's say initially we have the pressure of 8 atmosphere at T is equal to 0. Now in the parallel reactions, we know that if reactant A is giving us three different products, so initially we have P0 8 atmosphere. Let any time T, what will happen? Let's say we have P minus P1 minus P2 minus P3, right? Let's say A dissociates to give B with the pressure of P1, it dissociates to give C with the pressure of P2, it dissociates to give D with the pressure of P3, right? This is how we do it. Now what is it asking is that after 100 seconds what will be the value of pressure of B. That means in the end we need to find the value of P1, right? So we'll do one thing, we'll apply the first rate order reaction here. According to the first law, the rate equation will be Kt equals ln of P0 by P. And in the case of parallel reactions, the overall rate constant is equal to sum of individual rate constants. That means the net rate constant will be 6.93 into 10 raised to the power minus 3. This is the value of net rate constant. That means if we do the calculation, 6.93 into 10 raised to the power minus 3, the time is given to us as 100 seconds equals 2.303 log of, the P0 value is given as 8 upon P, right? Let's say this is P dash. This P dash value is this much. This is the P dash. P dash is the pressure of A at any time T, right? Now if you do the calculation, what will happen? It will be, we cut it like this and we have 3 here. So this is 0.3 is equal to log of 8 upon P dash. Now we know 0.3 is the log of 2, right? So this is equal to log of 8 upon P1. If we compare it, we get P dash. Sorry, it's not P1, it's P dash. Right. So the P dash comes out to be 4. Now this P dash is equal to how much? 4 equals P0 minus P1 minus P2 minus P3. So P1 plus P2 plus P3 equals 4. This is what we got, right? This is our first equation. Also, we know in the case of parallel reactions, the ratio of the products formed, let's say we know dV by dC, or we can say the amount of B formed or divided by amount of B C formed equals the ratio of their rate constants. That means it is equal to K1 by K2. Similarly, the amount of C formed divided by amount of D formed equals K2 by K3, and the amount of B formed divided by amount of D formed equals K1 by K3. Since we are dealing with the reactants and products in their gaseous state, so we will deal with not with the concentration terms, we will deal with the pressure terms, right? That means according to this equation, B upon C is equal to K1 by K2. That means it is P1 by P2 is equal to K1 by K2, right? Now K1 is how much? K1 is 2 into 10 raised to the power minus 3 and K2 is 3 into 10 raised to the power minus 3. That means K1 by K2 is equal to 2 by 3. This is one equation we got. Similarly, if we deal with this one, C by D, right? So C by D is P2 by P3. So K2 by K3, K2 is 3 into 10 raised to the power minus 3 and K3 is 1.93. So this is equal to 3 upon 1.93, right? And if we talk about this one, B by D means P1 upon P3. So it will be how much? It will be 2 upon 1.93. Since we need to find the value of P1, what we can do, we can take the values of all the P2 and P3 in the terms of P1 and put in the equation 1, right? So what we will do, P1 plus, now P2 is how much? If you look at this equation, P2 is 3 by 2 of P1 plus P3. If you look at P3 is 1.93 upon 3 of P2, right? And if you look at here, okay, we don't need to this thing, we need P3 in the terms of P1 only, right? So P3 in the terms of P1 is 1.93 upon 2 P1. This is equal to 4, correct? If I divide it by 2, multiply it by 2, net if you look at it, it is 6.93 P1 upon 2 equals 4. Hence P1 is how much? P1 is 8 upon 6.93. Now this value is little bit above 1. If you look at the options, there is only one value which is above 1, which is this one, option C. Hence the correct answer is option C. So this is how we utilize this concept to solve the question. If you understand this thing, it's great. Otherwise, just revise the concept of parallel reactions in the chemical kinetics and try to solve this question again.